So my name is Steve Marks. You may remember me from this morning as the guy who writes Hello World and wears ugly shoes. I'm a big fan of ugly shoes too. So this talk is about developing and deploying your first cloud service. It's marked as an intro level session. It kind of starts out that way. By the end, I think we're in sort of the intermediate territory. So if anyone's really scared about seeing some gnarly code, the exit's back that way. So let's get started. So this talk is for developers. This was the best picture I could find that represented a developer. This talk is about making things concrete. This, by the way, is Concrete, Washington, not very far from where I live. And this talk is about the present. So everything that I show you today, unlike earlier in the day and in the keynote this morning, this is all stuff that you can do with the October CTP of Windows Azure. So none of this is stuff that, oh, we'll be doing this next year or whatever. This is all stuff that you can absolutely get started and do today. And this talk is composed of 90% demos. I made that number up, okay? It may not be 90% demos. I don't want to disappoint anybody. The real statistic I can give you that I didn't make up is I was just practicing this in the speaker prep room, and I went through all of the code that I plan on writing, and the line count came out to 117. So for the mathematically oriented, that means one line of code every 30 seconds of this talk, and we're 2 minutes behind. So, there's quite a bit of code. I'm just going to go fly through code really fast. For those of you who are guru devs and understand everything I do, that's great because you'll get a lot out of it about how you use Windows Azure, how you do development. For those of you who aren't, go ahead and let your eyes glaze over and just sort of watch the general form of what I'm doing. What are the things that are interesting? I'll call out the things that are most important to pay attention to. So don't feel like it just if you're not comfortable with that much code that you're going to not get something out of this. So let's start with a demo. And this is, I call this demo 90% all at once, because I'm going to show you the application that we're going to build today. And this whole talk, by the way, is one giant advertisement for my blog. I'm going to go ahead and get that out of the way because you're about to see. I'm going to fire up Windows Live Writer, and we're going to create a blog post. I'll explain to you why this makes sense. So I already have a weblog set up. It is at blog.smarks.com. Maybe they need the HTTP. And I'm not going to tell you my password. Oops. My first demo already broke. Let me make sure that I've got the URL right. No! Hey, does someone want to tell me how to get a working connection here? Oh, right. Plug the cable the whole way in. Okay, this is my blog. It was plugged in. It's just it's missing the little tab. You know, when it doesn't click when you put it, it can pull out, okay? It's not... Don't laugh at me. Okay, so let's go back and let's try this again. It should actually figure this out for itself. Okay, it's doing a bunch of stuff. This is unsurprising. This is a Windows Live Writer demo so far. The interesting thing about this is that this blog is running on Windows Azure. So, hello from my PDC session. Why are you reading this instead of being at my PDC session? And let's publish. And hopefully it'll pop up and it'll be working. So this is all running in Windows Azure, and it's code that I wrote using ASP.NET MVC, using the storage capabilities of Windows Azure, and it's out there running in the cloud. It has been since the creation of my blog, and it's a great platform for that sort of thing. So this is the sample that we're going to go build up. Not exactly feature for feature, but we're going to go build something that lets you post blog posts, lets you attach images to it, and shows this all in a web UI. So that is the 90% all at once. So the quick overview is we're going to develop a service first. We're going to test it and debug it locally using Visual Studio. Then we're going to deploy it to the cloud. And then we're going to maintain a running service. We're going to look at how we can scale up, scale down, get the logs, take a look at analytics, things like that. So the key feature of development on Windows Azure is that there are no surprises. This sort of reaction is not allowed when using our SDK. What I mean by that is that we used everything that you're used to. So we used Visual Studio. We have these templates that help you out. We do debugging exactly the same way as you do in Visual Studio today. It's all built on the .NET platform. Remember that this talk is about today. So this is about the CTP, and in the CTP, it's managed code. So you have .NET, you have IS7, WCF, ASP.NET. That's sort of the platform that you're on. So hopefully technologies that are really familiar to you if you're an existing Microsoft platform developer. And it has this thing called the cloud on your desktop, which lets you run everything locally and see how it would behave when it's running in the cloud. And it's kind of like Cassini, or the web development server in Visual Studio. Okay, we had, what, 2 slides? So it's time for a demo again. And this demo is Hello World. Now, you saw me do this exact demo this morning at the keynote, for those of you who woke up early enough for it anyway. But I'm going to do it again, and this time I'm actually going to show you a little bit more of what's going on. So I'm going to create a web cloud service. We're going to call it Hello Cloud. And this time let me point out a few more things. So hello, we'll make it a little bit simpler. One thing I want to point out is these 2 files, the definition file and the configuration file. And these are the metadata about your service. And today, this is it. You edit some XML. It's actually fairly simplistic XML. In the future, we may provide some kind of UI on top of this. But the definition file says things like, there's one role in my cloud service, and it's called the web role. And it takes HTTP input. It runs on port 80. If it were HTTPS, then I'd put 443 here. And then if I have any configuration settings, in here I would put what configuration settings are available, and then in the configuration file, we'd give them actual values. Also in this configuration file, we say the number of instances. So if I had more than one role, you'd just see this thing repeated. So this is just XML, and that's what goes into the cloud service when you go deploy. That's how we understand your application. Okay, and I'm going to hit F5 again, just like I did this morning. Or I'm going to try. I'll click the button. And this is going to launch that, the cloud on your desktop, as I called it. We have this concept in the cloud of a fabric of connected machines, and that's what your code runs on, is this fabric of servers. Locally, we call that the development fabric. So what I didn't show you this morning is there's a UI behind this development fabric UI. And here we can see the roles of my service. I actually only have one called a web role. If I had multiple instances, you'd see more than one here, but here in my simplest form, I only have one. And this is actually the simulation of the actual cloud. So here it's just running locally as multiple processes, and in the cloud it'd be running on multiple servers. So let me shut that down for a second and show you the same thing again, but from the command line. So we do have to, you've seen me run a couple things as administrator. You actually do have to do that in the CTP. You can't launch that dev fabric UI without doing that. So let me find Hello Cloud. So this is the exact same thing that we were just working on. And you'll see I have 2 nodes here. One is that Hello Cloud that now I have a directory for it, and that has the CS def file and the CS config file. And then in the web role, I have my default.aspx. So this is the same thing we saw in Visual Studio, but here it is on the command line. And I can actually use these things to go build and package up a service. So for example, let's go into Hello Cloud, and we'll see the def file says things like what the web role is called. It says it's called web role, right? And actually, let me go to, we can do 2 things at the same time. Let me show you the Hello World that ships with the SDK. So this is a similar sort of thing. It's almost exactly the same thing. It's got a Hello World project, and it has a web role in it. And the reason I'm cheating and using this one is because it has this nice little command script that does everything for me, so I don't have to remember how. So the build me thing actually just launches Visual Studio to build this. It just does an nmake, basically, over all these things. And there's also a run me, and every sample has this in the SDK, so you don't actually need Visual Studio. You can run all these things from the SDK using run me. And run me basically does 2 commands called cspack and csrun. and CSPack basically takes the definition file and then the configuration file that you want to do and creates out of this a package. CSRun then takes the package that you produced and the config file and runs it. And so I'm just going to use the command line thing and skip it, but you guys can go look at exactly what this does. And this is going to do the same sort of thing that I did in Visual Studio. It's going to run it, it's going to launch it here. If we go to the development fabric, we'll see the same sort of thing. Here it is in this web role running. So if you can do it from the command line, and the reason that we did this, the reason we built it in this way with the command line as the basis, and then we built this Visual Studio integration on top, is that if you can do it from the command line, you can do it from pretty much anything that you want to. And so to sort of underscore that, I'm going to show you a proof of concept that we've done in Eclipse. So we've actually taken those same command line tools that Visual Studio builds on top of, and we've built a plugin into Eclipse that lets you do the same thing. So here, we have that hello world sample that comes with the SDK. And when I import it, here you'll see we have a default.aspx. Here we're doing a kind of code behind, set the label. And here I can just do right click, run as a cloud service. And this again, this calls the same thing. It calls CSPack, it calls CSRun, and then it launches this thing in the same thing. And Development Fabric will show this if I refresh. There we go. And this is sort of just a browser embedded in Eclipse, but it's the same thing. It's hosted on port 81 on my local host, just like it was when I did from Visual Studio and from the command line. So the idea here is not, I don't want to tell you we've shipped an Eclipse thing as well. This is a proof of concept. The idea here is that this shows the extensibility of building on these command line tools. So you could do this with any IDE you want. You could build any sort of rich set of tools on top of this. If you don't like editing the XML, hey, you could build on top of that. The idea is what we've done in this first CTP is set that groundwork and set a set of command line tools and basic building blocks that we can build on in the future in a variety of ways. So you may be asking the question at this point of, so what? So I showed you default.aspx and I coded some stuff and I ran it. And the point is, that's what ASP.NET does today. What are you doing for me that's new? And the so what is really that we got all of this for free. We got all this scalability for free. I wrote a default.aspx page, but now I've got multiple replicas of that. I can say run 10 copies of this. I can say run this across an entire data center if I want. Set up a load balancer in front of it. I don't have to do anything new. All I have to do is change a number, right? And that's actually the point that I want you to carry away from the development story of Windows Azure is that if you buy into this programming model, if you use our tools, if you develop in this way, scalability is actually now a feature of the platform, not something that you have to go do something to get. So you got scalability. You also get availability. It turns out those are nearly the same kind of concept. By doing this replication, you also get this property that if something goes down, there are other copies that stay up. You get the ability to do zero downtime upgrades. So I can write a default2.aspx, and I can go deploy that, and we can deploy it one copy at a time, so the other ones are still up running the old version during the changeover, right? And so that way you have no downtime. Everybody gets sort of a smooth upgrade experience over a period of time. And we did this all with existing tools and skills. So let's talk a little bit about horizontal scaling. And horizontal scaling is a really simple concept. It says, I've got my code. It's running on a single server. The way I'm going to scale is I'm going to add more servers. Right? It's actually the simplest way you can think about doing scaling. So instead of going out and buying a larger, beefier server, the idea is that you'll never be able to keep up that way. The way to do it is to just continue to scale out. The question arises, what about state? And as an example, just think about a shopping cart. If we're doing e-commerce, customer comes in, they land on one server, and they click, yes, I'd like to buy this. And then they come back and they say, all right, I'm ready to check out. They land on a different server because we're load balancing across all these set of servers. And now their shopping cart is empty because that state was located on another physical server. Right? It's the same problem you have today if you do programming against a web farm in ASP.NET or anything like that. Right? Once you do this horizontal scale, you have this problem of where does the state go? How does it get shared? And the solution for this, in all cases, is to use a durable store. So separate that state out and say, okay, none of the servers have individual state that's different from anyone else. They all go to the central durable store where I will maintain all that state. Right? And so in Windows Azure, we have durable storage. So we have a storage system that is durable, scalable, and available. because it has to scale just as much as your horizontal scaling front-end servers, right? It has simple abstractions like blobs, tables, and queues, and actually we're going to use all of them today in the coding samples. And it has a very simple interface, and it's just HTTP, it's REST, and we build on top of ADO.NET data services, which I hope a lot of you have been hearing a lot more about over time. But that's our solution for how do we expose data over the internet, is really using this protocol of ADO.NET data services. So let's do another demo, and let's take a look at some storage. So I'm going to come back here, and I'm going to actually switch to something that's already in flight. Actually, I need to make a copy. See, blog.start is where I start. Let me make sure I do a /s. Okay. Let me open that up. And this is basically the skeleton of our blog service. So I'll tell you what I haven't shown you is I just created a new service. I called it blog, and I created a blog web role. And this is actually using the ASP.NET MVC stuff. So I don't know how many of you have been playing with the model view controller stuff in ASP.NET. It's actually really cool. The reason I have this pre-populated is because out of the box, if you try to add an MVC project to your existing Windows Azure solution, it won't work. It won't actually get hooked up properly. And so we have a sample of how to do this. It's basically this. It's a zip file that just sort of has an empty MVC thing in there. So look for that to be blogged maybe on the Windows Azure blog or on my blog very soon. So that's why I did that. So we basically have this already. It's empty. It's got no controllers, no models, no views. So those of you who understand ASP.NET MVC realize this can't do anything. All that's here is sort of the skeleton for it. And what I'd like to do is we'll start off by making an image repository. So we're eventually going to try to build up to this blog. But one of the things we need to do in the blog is we need to be able to host images. So I'm going to create a new controller, MVC controller class, and we're going to call that images controller. And we're going to have the ability to do three things. We're going to have the index itself. We're going to have a page that lets you upload a new picture. And then we're going to have a create that actually handles storing the picture once you've uploaded it. And then we're going to have an index, and that's going to actually view all of the images that we have. So we want to use the durable storage that we have in Windows Azure for this. And the first thing that I'm going to do that is I'm going to add a reference to the storage client library that is a sample that ships with Windows Azure. So the storage client library basically takes that REST interface that I talked about and turns it into a set of .NET objects that lets you do a more object-oriented use of this. So I'm going to just bring in that sample. And let's start by creating that new page. So we're going to need a view. We're going to need a folder for the images, and then we're going to put a new view. So you want to upload a new image. We need a form. It's going to post, and it's going to post to the create action. And because there are files in here, we have to use an encoding type of multipart form data. So then here we're going to have an input of type file, and we're going to have a submit button. Okay, so that's it, and that's going to actually post back then to the create view, right? To the create method in here. So here we have to handle those files and do something with them. So the first thing I'm going to do is I'm going to get a container from the blob storage system. So the first thing we're using blobs in this example, right? So I'm going to create a container, and I'm going to create a blob storage object, and I'm going to use a little helper here, which gets my configuration info from that csconfig file. So this gives the account name, the account key, and whatever. We're going to have to actually go fill that in. Once I have that, I'm going to get a blob container that's called images. And from there, I can do a create blob. So I'm going to actually loop over each of the file names in the request, each of the files that comes in the request. And I'll get a variable that has that file in it. We'll use a blob name of just the file name that we get from the file that was uploaded. So we'll just get the file name from the file that was uploaded. And now we can call create. So we're going to tell our container to create a new blob. And we need three things here. First, we need some properties about the blob. What is it? What's it called? So the very first thing is the name. In here, we also put the content type so that we preserve that so that when someone requests this in, say, a browser, it has the right content type with it. And then we need the actual contents of the blob. So I'll use a blob contents object. And in here, I'll use this version. I'll use a stream because the file input stream is available to me. And I'm going to say, no, don't overwrite, just in case this has already been uploaded. I don't want to blow away any data. And then finally, we're just going to redirect to the index page. Let's build and see what I've broken so far. Nothing, this one, because I haven't filled it in. Okay, so in the index page, how do we view these things? So basically, that's the code here. We got a container. We called create blob to actually create the blob within it. And now, how are we going to get the list of all of these? And to do that, we're actually I'm going to copy paste the container line. And we're going to return a view, and what we're passing into the view this time is a call to list blobs. And list blobs just gets me, as you would expect, a list of all the blobs that exist. It takes a prefix. Here we're just going to go from the top. And this combined common prefixes basically says, treat my stuff as though it's in directories. So in the storage system in Windows Azure, you really have containers at a top level, and then you have blobs, and the blobs can have really long names. You can put slashes in those names and treat it as directories. So I'm going to say yes, treat it that way. And that means that if something's below a slash line, I won't actually see it here. And then I'm going to use a little link trick to get the ones that are of type blob properties. So some of them will be blob properties, and that means it's a reference to a blob. Some of them will be a reference to a prefix. So remember I said you can treat these like directories. Because I'm doing that, I'll get some that are just a directory name and don't actually represent a blob. And we're going to have to create one more view now so that we can actually see this, and that's going to be the index view that'll show us all of the blobs that are in there. So we're going to have an image index, and we're just going to enumerate for each. Let me actually do it as a strongly typed view. So I'm going to take an IEnumerable of type blob properties. And that means here I can just say, give me each of the properties in my model. Let me rebuild so it gets the typing right. Okay. So within there, we're just going to show some really simple UI. So we're going to make a div. We're going to put a link that points to the URI and also has the text of the URI so that it's easy for us to see what's going on. And then has an image which has a source of the same thing, that URI. So basically all we're using from these properties is the URI so that we can see that everything's working. All right, let's go ahead and run it with debugging again and see what mistakes I've made so far. Hey, I thought of one already. So remember I said that storage account info, I had this little helper that said get default blob configuration, blob settings from configuration. I never actually went in to find those, so let's do that now. And so here are the settings you need. You need the account name. You need the account shared key, which is basically your password. And you need the blob storage endpoint. Where are we actually going to get these blobs? And then in config, you have to define all those things. So let me copy paste the ones we're going to need. I pressed something bad. Here we go. and we have to give them values. So there's a special account called devStoreAccount1, and it's used by all the samples, and the reason for that is that it actually exists on your local machine. So when you're running this in the cloud on your desktop mode, this is the account that exists there. It's at localhost port 10,000, and I don't remember the shared key, so I'm going to go look it up, and I'll show you why I don't remember the shared key. Here's one place where it is. I just couldn't memorize it. I spent 3 hours in the speaker prep room doing nothing but memorizing this, and it wouldn't work. So it's a really long key, and the reason is it is really the secret key. This is what protects all of your data. So this is what makes it secure. It has to be long enough for that. So I'm going to do one more thing too. I'm going to set up that path. So remember, we looked for this container called images. I want to make sure that it exists before I do that. And so in the application begin request, I'm going to need a reference again to my sample client library. In the begin request, we're going to say same thing we saw before. Storage account info, get default blob storage account info from configuration, get a blob container called images, and create container. I could leave it like this, and what this would do is it would create a container for me called images, and by default it would be private, which means I'd always have to provide this key if I wanted to get access to it. But what I want to do is host images for my blog, and so I want anyone's browser to be able to reach those images itself. So I'm going to pass in something called a container access control setting. I'm going to say public. So I'm going to explicitly make it public, which means anonymous access is allowed for anything within this container. So every blob I put in there, you could just browse straight to in the browser. You could get without having to provide any authentication. Okay, now I believe we can actually run this. It is going to pop up with an error message, but that's only because I haven't defined a default route in ASP.NMVC. So to get to the controller that we want, we have to go to images/index. And here you see, hey, I've already been playing with this for a while. Fortunately, it works. Let's upload a new one. Let's browse and find some pictures. I love the green sea turtle. Okay. Submit. Hey, that's not it. Refresh. Here it is. Okay. So they're in probably alphabetical order, I believe. I think ordering isn't really guaranteed in the blob. So, so if you want some particular ordering, name them that way. And actually, we'll see an example of that when we talk about blog posts. How do we make sure that we get them in the right order that we wanted them in? So as you see, I can go straight to this. So I can go straight to this devStoreAccount1 images green sea turtle.jpg, and because I marked that container as public, I can get to it whenever I want to. The same thing happens against the real cloud. So actually, it's a link. So right here, I tried to entice people to come to this talk by telling them it's so much demos. This is the same thing, except this URI, instead of 127.0, instead of the local one, the development storage, this is the actual storage running in Windows Azure. So this is my account Smart Storage. This is the Windows Azure URI, and images is, again, the container that I used in the actual running version of this blog. So that's why we marked it public. All right. So I'm going to close that down, and let's quickly write a handler for the actual blog posts themselves. So we're going to write a post controller, and I'm going to make that the default so that actually when we browse to this thing, we get straight to our posts. And so before I do anything else, so let me explain for a second that what we're going to do here is we're going to use the structured storage. So we use blobs. We're about to use tables. So we're about to use the structured storage that exists within Windows Azure. And so I'm going to create a data model first for that. So I'm going to create something called a blog context. And in here, I'm basically just going to set up some rich kind of classes that will store all my blog information. Right? So I'm going to, again, need to use this sample storage client library. I actually need something else, too, that I haven't added a reference to yet, and that is system.data.services.client. And that's basically the ADO.NET Data Services client-side support. So this gives me C# objects that let me talk to that REST protocol of ADO.NET Data Services. So let's create a blog entry, and I'm going to derive from a table storage entity, and that's what you need to do to get the storage client library to help you out here. And we'll have titles and bodies of blog posts, and we'll have the time that we posted. And I'll define one parameter list constructor, and you always have to have a parameter list constructor because when you retrieve data from the table storage in Windows Azure, it needs to be able to create a new instance of blog entry and then fill in the values. So you always need one parameter list constructor. And in here, we're just going to set the posted time to the current time in UTC format. And we're going to set a partition key and a row key. And I refuse to tell you much more about either of those. You're going to have to go to the storage talks to learn a little bit more. But the idea is the partition key defines how your data is partitioned across physical servers. And in this case, I'm putting everything in one partition for my blog. And if I had multiple blogs, I'd put those in different partitions. And the row key is basically a unique identifier within a partition for this row of information. So here I'm going to use a trick that I've become quite fond of, which is I'm going to format on a fixed length a date time that goes backwards. So let me type it out here, and I'll explain for a second. So the row key defines the order that you get the rows back in. There isn't order by. So I'm going to get the rows back in this order. And so the key is to pick a key for the row key that actually gives you things in the order you want them in. And so in the case of a blog, I want the most recent post first. Unfortunately, everything is in ascending order. So I need something where each new blog post has a lower value than the previous one. And so the way I've done this is basically turn a date time around. I've said take the maximum date, subtract the date now. And so as time goes on, we get a smaller and smaller number. So these things get inserted above and above each other in the table. Right? So that's all I'm doing here. And then I'm going to create a friendlier constructor that takes a title and a body, calls that parameter list constructor, and also sets those things to what I passed in. And now I'm ready to create a context object that encapsulates that. So this is going to drive from table storage data service context. And if you played with ADO.NET Data Services, this data service context stuff, that's where it comes from. We've sort of added a little bit on top. And all that I'm going to have in here is I'm going to have one public property that returns blog entries. And we'll call it blog entry table. And when we get it, we'll just return a new query of type blog entry over the entity set called blog entry table. So that's basically the table name there, is blog entry table. So build and see where we are. Before I can make any use of this, and this is a thing only for running locally, before I can make any use of this, I actually have to set things up locally. Locally, our underlying implementation of the development storage is to run on top of SQL. So SQL Express, you'll see, is actually a prerequisite for running anything that uses tables on the local machine. So on the local machine, we have an extra step here, which is that I have to go to my project and say, create test storage tables. And basically what that does is it looks for anything here that derives from table storage data service context, and it creates a table with this name and with columns that map to what the type of object is that gets returned from that query. So this is sort of just a setup step for this. I'm also going to, just as we did with our blogs, I'm going to, right up front, make an explicit call to create those tables. And this is particularly for when I'm running in the cloud. This is actually the step that really creates the tables. That other step is an offline thing only. So I'm going to just use that blog context thing that we've just created. And there's this nice little helper function that does this. You might ask, where was the account information for this? And it's, again, defaulting to using our csdef and csconfig files. So I'm going to add one more setting, which is the table storage endpoint. And that one is hanging off of port 10,002. Queues are on 10,001, in case you're wondering. So I now have a functioning thing that has this new kind of model. Let's go ahead and use it. And so we're going to do a very similar thing that we did for the images. And so I'm going to try to get through that part pretty quickly. But we're going to create a new controller. And we're going to call it posts controller. And the index is going to just use that new thing that we created. So our blog context has a blog entry table property, and I'm just going to enumerate over that. So basically, that's going to be an IEnumerable of blog entries. So we're going to return a view that uses those. Our new method is just going to let us type in a new blog post, and then that's going to post back to create, just as we did before. And this time, we can use some niceness in ASP.NET MVC to automatically bind stuff for us. So we're going to say bind with no prefix. And if this is completely unknown to you, take a look at ASP.NET MVC. This has nothing to do with Windows Azure. This is just ASP.NET MVC. And in here, we're going to make a new reference to our blob context. We're going to say add object. We're going to give it the entity set name of blog entry table, because that's what we called it. And we're going to pass in the entry. And then we're going to say save changes. And then finally, we'll do like we did before. We'll return a redirect to index to go back to the main index when we're done. OK, so we need two views here. We need the new view and we need the index view. We'll put those under posts because they map to that controller. And let's do index first. So the type of the data that we're getting is an IEnumerable of blog entries. So in here, we can say blog index, and we'll do the same sort of thing we did before. We'll say for each entry in our model, we will make a new div. We'll put a header 1 that has the title. We'll put a paragraph that says posted at, and we will get year, month, day, hour, and minute out of that. And then we will do the body of this thing. So that's basically going to enumerate over all the blog entries that we have. It's going to put the title, when it was posted, and the body in there. And then finally, we just need the way to create these. So I'm going to add one last view, and this is going to map to that new method in the controller. And it's going to say new blog post. And again, we're just going to make a simple form here. It's going to post to the create action. We'll put a table in here to make it look kind of pretty. Don't worry, it doesn't look that pretty when I'm done. And we'll get a text box called title with a size of 100. And that's for the title itself. Then we'll put in a body, and for that we will use a text area. And I'm just making them the right size so that they kind of look right. And on this last one, we'll just put a submit button. So input type of submit, and it will say submit. And I'm getting red squiggly lines, but I believe if I rebuild, it'll actually realize. I think it's just an MVC weakness at the moment. Yep, those are valid when I type there. Okay, so I think we're there. Let's go ahead and run this. And here we see development storage popping up. It's making sure that everything's started and the tables are pointing to the right database entry. Remember, we made in the back end in SQL, we made this work. And it's going to fire this up, and let's see how far we got. I keep hoping silently that something breaks with an exception, because I'd really like to show you Visual Studio debugging. But so far, I've been unlucky enough to not make too many very terrible mistakes. So let's go ahead and create a new post and see how it goes. So here is my new post. What do you think? Submit. Hey, here it goes. Okay, and of course, we can combine these things. That was sort of the whole point. If we go back to the images, we can take, let's see, what's my favorite? Here's Ray Ozzie. Let's grab him. Okay, so, did I just say, let's grab Ray Ozzie? Good thing no one's recording this. Oh, wait. Okay, let's create a new post and says, Ray. And we'll put a link to our image, make it a little bit smaller, and there we go. There's Ray. Okay. So that was storage. So we saw a couple things there. We saw blobs up front, which was when I'm storing the images, they're basically files. Think of them as files. The blobs are just a big sequence of zeros and ones. We'll return them back in the same order you gave them to us, right? That's the blobs. And then we saw tables, which is actually adding structure on top of that. It's a very simple kind of structured data. It's just a large distributed file system with some structure added on top of it. But that let us store things like blog entries with a couple different fields. And we could even do things like queries on top of that. So I could say, oh, give me all the titles that have this word in it, or something like that, and basically do some enumeration for them. So we started here. We had our default.aspx. We load balanced across a bunch of instances of it. We added storage. So we got blobs, tables, and queues. I didn't actually show you any use of queues yet, but we can squeeze in a reference to it soon. And I want to point out at this point that this stuff is not just about websites. I have this problem in that all the demos I do tend to be websites because they look good. I know it didn't look that good, but they look better than something that runs and spits some stuff out to the console. And the problem is that it undersells Windows Azure. Because Windows Azure isn't just about creating websites. You don't have to have any UI whatsoever to your Windows Azure service. You can run anything that you want to that's sort of .NET code that can run in our trust environment in the cloud. And we'll just spin it up and run it. And you can do anything you want. So there are a lot of things that you might want to do in the cloud. You might want to do bulk file conversions. You might want to upload a bunch of things and convert them to a new file. You might want to do some heavy analytics. You might want to go over all this data and come back. And you might want to find extraterrestrials. This is actually something that SETI at home has been this huge success of people basically distributing work across a bunch of machines to help solve the problem faster. You could find really big prime numbers. You could hack into people's accounts by breaking their really big keys, right? There's a lot of stuff that you could actually use a cloud for that has nothing to do with websites, that has nothing to do with UI, that has nothing to do with that. Even websites can offload asynchronous work. So you might have front ends that are receiving data and they're just not touching it at all. And in the background, as is possible, asynchronously, some processing is happening to those. We can use that in the blog infrastructure that we've built. And don't worry, I'm not going to code all of this. But what we're going to do is I'm going to upload a blog post. It's going to have an image in it that's somewhere out on the web. I don't want to later get a broken image link when somebody moves that. So what I'd like is that when there's time, meaning asynchronously, I'd like to go get that image, store it locally in blob storage, and change the blog post to point to that one instead. Right? This is actually, I mean, it's a reasonable thing to do, right? And so to do that, we're going to need a more complex architecture. We no longer just have this web role that just spins up and runs when someone comes in from HTTP. So this is basically what we've been looking at. We've been looking at this architecture, and there are 3 of these that we support today. And the first architecture is this one. It's a web role, it's ASP.NET, and it talks to storage. There's a second one, which is just a worker role that also can talk to storage. And this is, for example, if you did that bulk file conversion. There's no UI at all. This is just a worker that sits there, spins, and talks to storage. So load all your data up into storage, spin up a bunch of workers. They'll go work on that data, and you can shut them down when they're done. And then you can combine them. And that's how we would accomplish something like this image, this local downloading of images. So from our default.aspx, we would handle insertion of this blog post. We'd store it all in storage. The worker would asynchronously look over all those posts as they came in and fix up any of those links and point them to some local version of the image instead. So this demo is actually going to be a bit quicker because I am not going to type anything. That's not true. I'm going to type a little bit, but not much. So I'm going to add something that's already existing here. I'm going to add an existing project that I wrote earlier called Image Replacer. And it does exactly what we've been talking about. And I'll just pull up the code and quickly walk you through it. It uses the queue, which we haven't seen before. And it basically says, forever, go get a message from the queue. The message is going to say the name of some blog entry. It's actually going to give the row key. And so it's going to look up from the blog entry table where the row key is equal to what I found, find all the URLs that are in it that point to images, go fetch them, use a web request to fetch them, store them in a blob in our images container in blob storage, and fix up the body of the blog post, change everything to point to this new one. And then it's just going to say, okay, now use this local version of the blog entry that I've changed, submit that to the server and save it, and then finally delete the message from the queue. And so this is actually interesting. I do want to highlight this line, this queue.delete message. We already got the message, right? We got the message up here. You'll notice it's not called DQ, it's called getMessage. And there's a reason for that. When you build reliable queues, to ensure that this scenario doesn't happen, you need to do this. So the scenario that you're worried about is I retrieve a message from the queue, I start working on it, and then I die. I crash because something bad happened. My server bursts into flames in the data center. I don't know. The hard drive fails, whatever. I want to make sure that somebody else picks up that work and actually does it. So what getMessage does is it says, I've got this message, don't worry about it, hide it for a specified period of time. And if I don't come back to you within that specified period of time, show it again. Put it back on that queue so that somebody else can grab it. So what I have to do is I have to say, okay, I've got it, hide it, and then when I'm done, say, okay, go ahead, it's done, delete it. Right? So it's sort of this two-phase dequeuing. So this is going to take care of doing all this work for us. The one thing that we have to do is we have to queue up the work. We have to put an item onto the queue that says, anytime we create a new blog post, go do this. So we just need to add a little bit of code to our create method. We're going to say queue storage. Oh, I haven't added the reference yet. So we're going to refer to our sample client library yet again. And I'm going to say queue storage.create. And this should look a bit familiar by now. Default queue storage account info from configuration. And then I'm going to get a queue called entry queue. And we'll just store that as my queue. And then I'm just going to say put message. I'm going to make a new message, and I'm just going to put some text in it. You can put anything you want, but I'm going to use text. And I'm just going to say the row key of this entry. And that's nearly all we have to do. We have to, again, as we have for all these other ones, we have to make sure that it's created up front. So we're going to get that same queue, the entry queue, and we're going to say create queue. So it's very parallel to these other things. And then, just like with the other ones, we're going to have to use the definition file and the configuration file to say where is this queue endpoint. And I think I've already revealed that, startling enough, it's at localhost and it's port 10,001. Hey, thank you for the people who murmured that there was an issue. I think everyone was thinking just then, like me, is it okay if I put 01 there? It probably is, right? I'm scared to try. Okay. So we've added this thing, but what we haven't done is we haven't hooked it up. Look at this. Remember that this is the architecture of my service. And so far it just says there's a web role and it's called web. Where is this worker role that we added? We're actually going to use Visual Studio to do some XML editing for us. And we're going to say, go ahead and add a role and use this thing in the project to do it. And it's going to go ahead and insert this for us. What it doesn't do for me is copy the configuration settings. Each role has its own set of configuration settings. And so if I want them to share these things, I've got to do the copy pasting between them. So let me just take all the same configuration settings we had and put them there. And I believe we're ready to run. So for this, we're going to need a picture that's out on the web. This is the most dangerous thing I've done on stage so far. I'm going to search the web for pictures. Okay, so this looks safe, right? Okay. There are no pictures? That's disturbing. Everything, we're going to be profitable? Good. That's good news. Let's see. Okay, hey, this is a picture. Maybe it's not a very big one. Here, we'll open it up full size. Full size. Okay, so this is the URL courtesy of Reuters. Thank you very much.
Gates, by the way.
What's that?
It was Gates.
It was Gates? It was a picture of Bill Gates? He wasn't even at this event. I didn't even pay any attention to what it is. Okay, it's too bad we're putting him in this post anyway. Who is this guy? We'll make it small again. So, width 300 pixels. Anyone know? Okay. Let's go post that. Hey, where's my picture? Image source. Did I do something wrong? Anyone see it? Oh, it is there. Properties, here we are. Okay, so this is the image coming from the outside, and if we've done everything properly, I should be able to sort of control refresh here and see that we didn't do everything properly. Everyone imagine that it worked. Let's debug it. Excellent suggestion. Okay. Where are we? Let's go to our worker role. This is actually a good example of debugging. Okay, we're going to go in here and we're going to set a breakpoint. And, sorry, the function keys don't work up here. How do I do it? I click it over here. Okay, so we're going to set a breakpoint and we're going to see if we ever hit it. I have a feeling that what's happening is we're not actually enqueuing the message. And so to check that out, I'm going to use one of the samples that comes with, I can do it from here. So one of the samples that comes with Windows Azure is actually called Cloud Drive. And Cloud Drive lets you use it's a PowerShell plugin, and it basically lets you use the storage in Windows Azure as though it were a drive on your system. So I'm going to say mount drive, and I'm going to go to the queue. And there's an entry queue, and it's empty. That seems like the culprit to me. Let's look at the blobs, by the way. These are all the images that have gotten stored here. Okay, so why is it entry? Why is it empty? Sorry. Let's set another breakpoint where we are putting the message on the queue. Okay, so let's do our post again and see what's happening. Post new. Really, who is he? Image source, same thing. With 300 pixels. Submit. And hey, we hit this line. Okay. So let's step forward. Okay, without the function keys, what do? I want to step over. I press F10. I don't know what to do otherwise. And let's see, we do have an entry with a body. That's correct. The queue points to entry queue. We've put the message. That really looks like it should work. I'm stumped. And hey, we've hit our breakpoint here. So this is in the worker role, which means we did actually pull the message off the queue. So I think the problem is that my regular expression parsing is no good. We'll see. Tries to get it, stores it, replaces. Didn't find any other ones. It updates the object, it saves the changes, it deletes the message, and it throws an exception. One of the request inputs is not valid. What a helpful exception. All right, I think I'm going to declare defeat and say my demo is simply not working. You know what it means, though? We did see it actually. Is there a new file here? There is, isn't there? No, there isn't. I lied. There is. This one. Let's see if it's the one that I think it is. So let's copy it out to demo user. That's who I am. And, wow, I should have renamed it in the process. Let's rename it to something .jpeg. Was it a JPEG? We'll find out. Foo.jpg. Hey, okay. So some of our code's working, and some is not. All right. I'm going to leave it at that. It's going to be a mystery I will solve later and post to my blog. So sorry about that. Okay, so we added a worker role. So basically, we took our web role that we had, our default.aspx, and actually a bunch more, and our web UI, and we added to it a worker role. They share the same storage, which means that we can use things like the queue to pass data back and forth to do things asynchronously. Right? So that's basically what we added there. Hey, we already did the debugging part. I don't need this slide. But debugging, let's talk again about debugging, because I actually want to differentiate between what you saw me do here locally and what you do in the cloud. So remember the no surprises, that guy, the no surprises guy. For people who missed it, here he is again. Okay. Offline, you do just what you'd expect. That's what no surprises means. So in Visual Studio, you saw me debugging the web role and the worker role together. They're just two processes running on my machine. I can do all the normal debugging stuff. So I can set breakpoints, step into code, inspect variables, etc. I should have pretended that whole thing was intentional to show you debugging next time. What about in the cloud, though? So the question is, what about in the cloud? Can I attach a debugger to the cloud? Where exactly is the port to do that? The answer is that really debugging in the cloud means logging. So what you don't want to do is you don't want to stop your sort of production service that's supposed to be highly available, highly scalable, et cetera, and halt the whole thing so that you can debug on that machine, right? It's a shared environment. There are questions about how would we let you debug your stuff without letting you see anybody else's stuff, et cetera. So debugging in the cloud really means this logging. We have a very simple logging API today that looks, I call it printf. It looks very similar to printf. It's sort of, you can impose a little bit of structure, but it's basically a set of strings that you can log to. There will be a lot more functionality over time. So one of the things that we think is most important, and you're going to see from us in terms of logging in the future, is the ability to trace requests across multiple roles. So for example, I go in, I create a blog post, something gets queued up, later on some worker role picks up that blog post, tries to fetch an image, and something breaks, right? And so that kind of debugging scenario, if you want to understand what happened in the cloud, logging can be really effective if it has enough information that lets you trace through that. So we're talking about things like activity IDs. It's some things that may seem a little bit familiar to you if you've done some sort of service-oriented logging where you pass these activity IDs through the whole thing so that you can correlate logs again later. So things like that will come in time. This is something that we really want to focus on and do well. Right now it's a very simple API. So let me show you quickly just what logging looks like. Sorry, flip over this machine. And we'll stop debugging. And in this worker role, for example, we can do something like, we can log here. So we can say role manager dot write to log. And here we get to set which event log we want to go to. Critical, error, warning, information, or verbose. If it's critical, I will get paged. We actually have this all set up, not when I'm running locally, but in the cloud. It's set up to work with Windows Live alerts, and that means that I can set up and I can say I want to get an instant message, or I want to get an email, or I actually want a text message on my cell phone when you see a critical alert. So this is basically push error messages, right? The critical means we're going to push an alert to you. Everything else is going to show up in a circular buffer in the cloud somewhere, which means that you can go at any time to the portal and just retrieve your most recent set of logs. Up to the limit that we sort of keep around in that circular buffer. So everything else goes into that mode. The critical goes into this alert mode. So I'm just going to say this is really verbose. And I'm going to say got row key of, we'll format it, string.format, got a row key of message.content as string. So that's going to tell us whatever we got from that front end, and is going to log it here. And this way I'll be able to debug. I'll say, okay, what were we working on? So something didn't work. What was the entry that we were working on? This is the idea. Insert these liberally. There's actually a talk in, 2 days? Where's Sriram? I'm talking about Sriram's talk. Sriram Krishnan has this talk about best practices of doing this cloud stuff. And he's going to talk about the importance of logging and how to make this configurable. But the bottom line is you need to log everywhere, because that's going to be the way that you find out. Those are the breadcrumbs you leave yourself to debug this thing after the fact, after it's happened, when it's been running up in the cloud. So, back to the deck. Which one's the right one to make it start from here? Oh, hey, it wasn't that. All right. So what about publishing your services to the cloud? So the general step is you write code on your laptop, you upload your package to the web portal, and then you push deploy. Right? It's really about that simple. And then sometimes later, you go and you monitor, you look at your analytics, you upgrade, you scale the thing up, then you scale it back down when it turns out actually no one wanted to see it in the end. And that's the process. And I'll just quickly show you I'll show you the portal, and I'll show you my actual blog running up there. So I'm going to go to the Windows Azure portal. I'm going to log in as myself. And here's my blog. And it's up and running. And so I did the same thing. You saw me do it in the morning where I initially had this thing empty. I uploaded a thing. When I've uploaded my project, it's sitting in the staging bucket here. Ice cube, I call these. And it has this URL that's slightly obscured, but don't be fooled. It is public at the point where you've gotten into staging. This is a public URL that is live. So lock down. If you're doing testing and you're not ready to be live yet, lock down yourself in some fashion. But it's basically this gwid.cloudapp.net, and we can actually click on this. This is a different version of my blog, basically. And then in production, so when I'm done with that, I can kind of move it into production. And then that's how my upgrade cycle looks like from then on. So from then on, I can upgrade a new one as I have here. And when I'm ready, when I'm satisfied, this is the version of my blog that I want running. I click this button here, it swaps them. And so now that version that was in staging is actually the live version at the live URL. And the production one goes back into that staging bucket. So if you have to roll back, hey, you just click the button again and it swaps back into place. So the idea is to have sort of one that's production, one that's testing, and switch those roles every once in a while. We will be in the future doing a lot more in terms of rolling upgrades, give you a lot of dials to fiddle with, etc. Right now it's sort of just this swap. We swap them at the load balancer level. We reprogram a load balancer to point it from one to the other. If I want to get my logs, since I've just hyped up logs so much, I go here, I choose a storage account to put them in, and I click the copy logs button. And there's a slight delay to copying the logs, but they'll show up there in a few minutes, right? And then I can use Cloud Drive, and I can go take a look at those and see what it is. I've also created this storage account, and this is what I'm using for my blog, and this is the access key, which means right after this session, I have to generate a new key. But again, same thing. You sort of create a new storage account. You give it a name, which shows up here. It generates an access key for you. You can always regenerate at any time. We use 2 access keys so that you can do a staged key rolling, right? So that I can go to my new one, not shut the other one down until I finish my changeover, so that you're always available, right? So there's no period of time where your access key is no longer valid. There are also some analytics here, so I can see things like how much storage am I using. On my running application, I can see things like bandwidth, CPU usage, and things like that. Okay, so a little over time, but we'll still have a little bit of time for Q&A. The key points here are it's a familiar development environment. You could do all your debugging locally. Deployment is really a breeze, and the management is all automated after that. So you tell us what to do on there, and then we automate the actual process of doing that. Next, go to Azure.com and download the SDK, write a lot of code. Send me some mail if you write something cool, and I'd love to hear about it. Go to these talks. So there's a talk about, I don't have the actual titles here, but there's a talk about storage by Brad Calder, who's basically the architect and dev manager of our storage system. That's Tuesday, tomorrow at 1:45 p.m. On Wednesday, there's that best practices talk I mentioned with Sriram Krishnan, who's going to talk about why you should log a lot, among other much more interesting topics. And that's Wednesday at 3 p.m. in this room. And on Thursday at noon, also in this room, is the programming model talk by Daniel Wang. And there he actually goes in depth about what do we mean by .NET, what's the trust model, how does this stuff run under the covers. He's joined by Stefan Shakow, who's going to talk about .NET and how we're making these two things together better. And I want to give credit to the photos that I took from Flickr of the developer desk in Concrete, Washington. Thank you so much. I'm legally required to tell you that these sessions will be available in recorded form at microsoftpdc.com, and please do fill out your evaluation. It's the only way I learn. And let's have some Q&A. So please do go to the microphones that are there for Q&A. Thank you.
When you push to the deployment side from staging to the live production, could you do the selected deployment, like out of 1,000 files? Do you push all 1,000 files, or you can select only like 10 of them?
So when I'm pushing, like from staging to production, can I choose to only deploy some files?
Yes.
Is that what you're saying? No, it's actually, the way it works is really both services are running.
So it's a
We
mirror.
reprogram the load balancer. So there's actually that step isn't really a deploy step, it's a swap of interfaces.
Okay.
Right, yeah. Let's go here, we'll try to, yes.
In terms of the scaling, you had a setting for the number of workers or the number of nodes to sort of add a number of new web or worker nodes. Is there a way to auto-scale, or is that something that would be in the plans based on load?
Yeah, not in the CTP today, but yeah, that's something we definitely have intentions to do. Done automatically. Okay, over at this microphone.
When you do the transition from staging to production, what happens to the storage? And also, what happens if you have structural changes to the tables?
Yeah, that's a great question. Actually, Sriram will address that in his talk on Wednesday with best practices. I'll give you the mechanical answer of what happens. So what happens when you swap these, nothing changes. Whatever storage the staging one was pointing at, it's still pointing at when it's in production, et cetera. So the config comes with it. What that means is that if you're going to use a test set of data versus a production set of data, you have to make that configuration change before you do the swap. Like you'll have to flip over that testing, the staging deployment to point to your real data before you do the swap. If you have structural changes, like you change the shape of your data, the short answer is you basically have two options. One is turn it off, make the change, turn it back on, which is a viable option, right? The other one is do it in a backward compatible way. So do your changes in a way that you have code that can handle both versions. And Sriram actually will talk about kind of what that looks like. He even has an example really of how to do that. So I would attend that talk to find that out. Okay? And let's go to this one. I'm trying to do this programmatically. Yeah.
Yeah. I don't know if you have considered this one or we'll see it in future sessions. But what about third-party installations or third-party components that maybe a service needs to perform?
Yeah, so third party, I can think of two kinds of this, right? One is my running application in the cloud relies on some third party DLL or something, right? There's a second version of this, and I'm not sure which one you mean, which is actually my service calls into some other service that's running in the cloud to send an email, say, or something like that. Which one of those are you?
DLLs. Or an installation.
DLLs or on installation. So DLLs, you can package anything up you want to with your class. So if you have a license of something else or whatever, you can drop it there and go. Installation is a bit of a problem. So the programming model is very much copy deployment. If you can put it in your bin directory, it'll work there. I didn't point out at any point here, but we do run under a restricted trust environment. Mm-hmm. So there's a code access security policy in effect, and if you go to Daniel Wang's talk, he dives into exactly what it is. But it looks a lot like medium trust. It's similar to medium trust. So also make sure that the components you're relying on will operate under that trust environment too.
Okay.
Yeah.
Thanks.
Okay, here.
First, I want to say it's amazing. It's really amazing. It's at last the competition to Amazon.
Yeah.
Which actually took the space today. So good work for that. And the second is, are you planning to support system transaction? So I could do, because the get message, delete message doesn't work if you want to do real transaction work against that. So what's your plan about that?
Come to the storage talk with Brad Calder, and I think he'll talk about, we have some limited set of sort of transaction capabilities that are on the roadmap. Everything else is sort of being discussed still. Your observation about the CTP is absolutely right, that actually there is a transaction within a row. So it is the case that if you're setting multiple values within a row, that is an atomic thing.
But do you have
but
a
that's the
resource-
extent of transactions. So transactions across multiple rows or multiple tables or the
Between
queue and
resource
tables or
managers,
things like that.
between resource managers, if I want to do a transaction between two queues,
Yeah,
or
between
between
the
the
queues, right.
SSDS you call it, and the queues and other stuff.
Yeah, no transactions yet.
Okay. So do you support getting out from that app to an external SQL server that is not hosted?
Yeah, absolutely.
Yeah, okay.
So incoming traffic has to be HTTP or HTTPS. Outbound traffic can be any TCP connection. So you can connect up to a SQL database that's outside of our cloud if you want to.
Yeah, I think my question kind of follows what he was asking, and that is, as I was sitting here, I was thinking to myself, well, where could we use this at my company? And all of the projects I'm working on that are coming up soon require at least some amount of data from one of our enterprise systems.
Yep.
And so because of that, what would a typical integration paradigm, or what would the architecture look like to get that? And I think I heard the last bit about incoming HTTP, but would you have to expose a web service and worry about the typical VPN stuff? And if that's the case, are we opening up our enterprise system to all of the services on the cloud?
Interesting. Yeah, I think the answer is, and I could be wrong on this because I'm not from that team, but I think actually the service bus and the access control services that are part of the .NET services within Azure are the answer to that. I think that those support doing this sort of thing where actually you span multiple locations, you're on premises, you're in the cloud. How do I do the coordination and the communication in a safe and secure way? I believe that those are our answer to that, but I'm not extremely knowledgeable about them.
So is there a follow-up session, maybe the architecture one, where this might be addressed?
I don't know. Actually, the best advice is to watch the presentation that was right before this one. John Shuchuk did a thing about the .NET services in general, and actually a lot of the Azure services layer. And I think he probably talked some about this. So watch that video or look at the schedule. There are probably some follow-up ones on that in the future days.
Thank you.
Sure. Down here.
What are the limitations?
What are the limitations?
Yeah.
That's a rather open-ended question.
Say
Do you have
at least
specific?
one limit.
What's that?
Say something about that. I mean, like Google Apps, they prevent you from accessing network.
Yeah. So okay. So
you allow to do that.
the high-level limitations that I think people will care about a lot is in the CTP we're managed code only, although we will do native code next year. Incoming traffic has to be HTTP or HTTPS.
Network services.
The code access security is the trust policy that at present, and this will grow over time, but we're basically the medium trust code access security level, which means there's a lot of things that you can't do, but most things you can. I think those are the big ones that are going to...
Storage size is unlimited.
Sorry, say again?
Storage size.
Storage size. In the CTP, we do have some limits. So in the CTP, we actually have a limit of, I believe, 50 gigabytes of storage. There's no technical limit that's anywhere near there. I mean, we can easily have a single blob, be really huge. We can have terabytes of data, and it's not a problem for the system. But for the technical preview, we have some limitations in place. We also have a limitation in the tech preview on the number of compute hours you can consume. And I don't actually remember the number for sure off the top of my head. But the idea was to make sure that everybody has a chance to use this. So if people are sort of running something, they get done with their experiment or whatever, we want to make room for somebody else to try something. But those are all CTP limitations only. So I mean, in general terms, those don't apply.
Okay, thank you.
Sure.
So for the Azure hosting fabric, you really have, you're highlighting like the table storage fabric. When would you play with the table storage fabric versus using SSDS in your business cases on that? And would you always push somebody to the table storage, or?
Yeah, this is a great question. So I guess the general question is, right, there's this table, I've shown you now this table storage, which lets you store entities, and you have entity sets, rows, values, et cetera. SSDS also has something somewhat similar. They both use a REST protocol. They use ADO.NET data services. What's the deal? When would you use which? First, the observation is a good one that they're very similar. and that's highly intentional. We believe that ADO.NET Data Services is the way to interact with these things. We believe the idea of entities and properties is a good way to represent this data. The answer for when you use which is really sort of a question like, suppose you're on Windows today. You could store some of your data in the file system. You could store your data in SQL, right, in SQL Server. The decision of how you do it has to do largely with what kind of operations do you want to do. So the SQL services, as they fill out the whole set of their functionality, they'll be able to do things like rich queries. They'll be able to do things like analytics. They'll be able to do things like reporting and things like that. We won't, in the Windows Azure table layer, be able to do those things. So in Windows Azure Table, it's designed for efficiency, performance, and scale. So it's designed to just be a very cheap way to store all this data that's highly available, highly secure, et cetera. In the SQL services layer, the focus is get the functionality like I have in SQL Server today, right, and basically carry that analogy. So if you keep in mind the analogy of sort of Windows and in Windows Azure, and if you think of SQL Server in SQL services, that should give you a picture of kind of where those are both headed in terms of the direction.
Thank you.
Sure. Here.
So yeah, when it comes to debugging on the actual production side of things, I get that logging is important, but is there any plans to do any type of remote debugging in the staging area?
No plans as of yet. I'll say it that way. So that's something we'd like to talk about. That's certainly something we've been thinking about. There's no plan to do that in the near term. Okay. But check back with me in the future and we'll have solidified some plans.
Yeah, because printf debugging is really effective.
Yeah, understand. It's a little bit painful to not be able to use that, although it didn't help me at all to fix my problem.
All right, thanks.
Sure. And the boy down here.
The question I have is whether it can scale down so that it's not only on the desktop where you can test, but maybe on a server. So you have right now the development environment for the desktop, but can it scale up to the server so that you could install maybe SQL Server instead of SQL Express on the desktop, on a server instead, and have more developers having at it? And the other related is whether there would be or there could be an offering that would be, let's say, a private cloud.
Okay, good. So the first question is really, all right, suppose I want to debug and I want actually my whole team to be able to hit it. I basically want to spin up the services, not just on this local box, yes, but for other people to use. By default, we lock everything down. If you're not talking from localhost to the service or to the storage services, we won't accept the connection. And this is for security reasons. I mean, we don't want to open ports on people's machines when we don't have to. There are lots of tools that let you then just go do this, though. That let you, there's one that I've used called Net Redirector. I don't know how available that is, but there are a bunch of tools that basically let you remap and say, no, actually, when traffic comes in here, reroute it locally to localhost port 81, or for the storage services to port 10,000, 10,001, 10,002. So you can definitely very easily do that. It's still going to have the constraints of running on a single server, and so you'll still have to run on a single server. You can, by the way, use SQL Server, full-blown SQL Server instead of Compact Edition. I don't know if there are any gotchas there, tweaks that you have to do. I'll check it out and maybe make it a blog post at some point. But you can do that just to use if SQL Server is already on the box or something. To your second question, which actually kind of extends this, is, well, what if I actually wanted to run my application in my data center? Could I use this stuff and kind of run it across multiple servers or wherever? The answer is no. We have no plans right now to make this something that you could run yourself as sort of a private cloud. Talk to us about the scenarios and whatever. It's something we've heard people ask about. The short answer is we're not planning on doing it.
One case is, for example, homeland security applications. Mm-hmm. There are several, for example, 911 sites, military bases that have, they could have thousands of users, but you don't have necessarily, because of the confidentiality or simply sensitivity of the data, that you don't want that to be hitting the internet. So then another minor one is I didn't see anything related to MSMQ or queue services there. Is there anything that has to be deployed for queues in the same manner that for storage you're deploying, SQL Server?
No. So the queues are actually layered on top of, this is actually true in the cloud and on your desktop, that the queues are layered on top of tables. Okay. So they're just built as an implementation on top of tables. So locally there's nothing, once you have SQL Compact Edition, you're fine to run those things. Yeah.
Thank you.